So I'm just trying to cover some of the questions that we've seen come in. I think that's everything. All right. Well, Chris, I see you. If you guys, I'm going to go ahead and mute and you guys take it away.
Okay, we go ahead and get started. Perfect. Good morning, everyone. Chris Bettinger from Oldcastle APG. It's really good to see you all here. This is we've got 3 hours of me in and out of this stuff. We've got three great presentations. They're all Oldcastle APG University courses. So we always put our logo up there front and center. Instead of switching back and forth control, Ryan's going to prompt these few introduction slides so we can go ahead and move on to the next one. Today's course is going to be engineered porcelain, setting a new standard. Engineered porcelain's a totally different animal than what you run in out there because it's structural values, very high density, extremely low absorption rates. I don't want to steal any of Ryan's thunder. It's a really good presentation because it does show different things. We're going to talk a lot about rooftop here. We'll talk about the nuts and bolts, also the engineered porcelain, but if you can prompt it again. There's my contact information. Most of you already know me. This presentation is available. I think Hillary posted in the notes or wherever you guys can grab it. We do have a PDF of this, so these things are all there. If you don't want the whole PDF, you can do a quick screenshot here. The next slide, you'll see it has Ryan and Cynthia's name or contact information. They are a very, very, very valuable partner with us, the Mirage product line. We've been with them for, gosh, it seems like forever, probably at least 10 years now. Ryan is a sales representative out of the East Coast who does a lot of work with rooftop. I've done a lot of things in terms of submittal with Miami-Dade and talk about rooftop and worked on specification. Cynthia is our rep down here. She's very, very experienced with all this engineered porcelains and whatnot. She's also getting her feet wet with rooftop. We'll be in the background answering questions while Ryan's going through everything. A little bit about Oldcastle. We're a pretty diversified company in the state of Florida. We have 18 different companies running. This year, we're going to do probably $460 million worth of business in just the Oldcastle APG group, which is what I'm part of at Oldcastle Coastal. If you look at the presentation, you'll see hardscapes with our Belgard line. Everyone's familiar with that if you watch HGTV. Our packaged products, Sakrete, is a retail item. You'll see at Home Depot and Lowe's. Meramixes are more commercial or professional grade. You'll see it in pre-blended mortars, grouts, fillers, reinforcement, all different number of different things. We do a lot of stucco also in the whole in the Florida and Caribbean region. Echelon Masonry with our special products with the Trenwith product and a number of different cast stone specialties. We're also a distributor of products. We handle pretty much every brick line in the country. We have lawn and garden products also available. I don't do anything with those. So if you have a mulch question, you're out of luck. Composite decking, we deal with the Moisture Shield product, which we've had a lot of success with. We've done some presentations. I know Wendy and the team up with AIA post all of our presentations with APGU monthly on their website. So you'll see those. We love having people from Florida. We did one with the composite decking. It's a recycled product. It's one of the best ones out there. And then also we're very big because of the Belgard line. We have Barrette Outdoor Living, which is all sorts of accessories, fencing, accent items, pergolas, all different kind of things. So a little bit of everything going on. No, you're fine. I love this slide because it really shows the scope of what we do. So if you go down to the lower right, I am the architectural specification manager for the state of Florida, Southern Alabama, and Southern Mississippi. I also work with the National Checkoff program in the whole Southeast and part of the Masonry leadership team for the whole country. That's all good to know. But the thing about this slide that I really like is the fact that we can help you with a project specified here in Tallahassee, Orlando, wherever we may be. And one of our sister companies can help you if you're doing something in Oregon, let's say. So we can still do a number of different things with our CPM company. The point of that is we can help you with specifications here where you're doing the design work, but where the work's actually being implemented, we can help you with contractors who are familiar with the product. We can help you with budgeting and all those different things and availability. All of our stuff is on the Oldcastle Learning Portal. We have that available. Most of these courses that you've seen on our APGU is also available there. You're welcome to go there anytime you want for any of our courses. We just finished yesterday our Oldcastle APGU program for 2024. If you want to go ahead and prompt it, Ryan. We did one yesterday on masonry automation. We had about 500 people online. It went very, very well. In 2025, we decided to take January and February off. Our first course is going to be Lead version 5 with Tina Sabasic, who is very well known. She is one of the speakers that we hire in all the time to do presentations. Whenever we do anything with Tina, we usually have 750 to 1,000 people online. So it's always really, really popular. But the first one will be in March 6th. Then we're going to go back on our monthly schedule. January and February, after a boarding deadline of an even year like this, we typically don't have a ton of people that show up. We'll get 200 or 300. And everyone's sort of burnt out on courses because these last minute rushes they're doing in 2024. So we didn't want to go ahead and post something and really not have the bang for the buck out of it and all. So we'll be back in March of 2025. So sometimes it can be tough making these presentations online because you can't see people nod, you can't see them laugh at your stupid jokes, you can't, you just don't know where you're fitting in. So please post your questions in Q&A. We know you're participating. We'll answer them as best we can. Cynthia and I are going to be all over that. If we run out of time, we're going to have a little bit of a break. And since we're coming up right after this with another one of our courses, we can answer a couple questions here and there, but do not hesitate to email any one of the three of us. We'll be more than happy to engage you in whatever you need and questions regarding these products. We put a lot in these presentations and we want you to get a lot out of them. So it's really important to us. So today's presentation is Engineered Porcelain Setting a New Standard. This does qualify as one learning unit in health, safety, and welfare. Wendy and her team will be processing those credits. So they're taking care of all the registration and everything. We are a certified presenter, so we have this course available. If you want to do it at the firm level, it's not a problem. We can do it via webinar, in person, either one. So our course description, we're going to be talking about porcelain and engineered porcelain. Essentially, it really has no limits to it. It's very resilient because of low absorption rate. Fantastic strengths. It'll span 2 foot in a rooftop application. It is really a pretty powerful and diversified product. You can read that through, but the summary of it is you can put it on the ground, you can put it on a roof. We have a lot of people down here that take the wood plank look and they'll adhere it to a wall and put it vertically for a decorative look, a nice aesthetic. There's any number of things you can do with it. Today, we're going to focus in on that rooftop. But like I said, that is not a limit to this product. We can do pretty much anything with it. The learning objectives we're going to be going through, you can go ahead and prompt it again, Ryan, please. We want you to understand the technical specifications and the properties of porcelain pavers, primarily engineered porcelain. Engineered has a whole different density and the performance values are really off the charts when you look at it. The absorption rates are less than natural stone like a quartz or granite. So, it really does have some really cool applications you can get involved with. We want you to understand the different applications, but today we're going to be really focusing in on that rooftop paving system. A real safe surface for occupants of a building, resilient. There's a number of different things you can do. It's not bulletproof when we talk about Miami-Dade. Ryan and I have had a couple of conversations. Cynthia has been involved with them. This is not a catch-all where it's going to work in every application on a rooftop. If it's adhered down, yeah, it's great. But when we're talking about, on pedestals, because you're absorbing the roof grade, you still want positive drainage and all those different things. There are some things we have to look out for, and it's not going to satisfy every specification. But I think it's a good choice to consider, and we can help you get through that process before you get too far into it to know if this is a good one for you. We want you to understand the safety factors, what's engineered in it to make it a safer choice when you're putting it on a roof. And we want you to understand the current installation of the porcelain pavers and the current codes and best practices and how they all fit in. I'm going to sign off here. I will be in the background answering questions. We'll probably have a little break in the middle here where we'll talk a little bit, but I'm going to hand it off to Ryan. And thanks again, Ryan. We'll let you go ahead and get started.
All right. Thanks, Chris. Pleasure meeting everyone. And we're going to just jump right into our rooftop application. Here's a project that was done in New York. So again, today we did the introductions, but we're going to go into why we're going to design with porcelain pavers, some of the components that are involved in this. One of the more important aspects of this is the safety aspect, and then design and installation process. So some of the key factors when using porcelain pavers Not only can you use them for indoors, you can use them for outdoors. They're thicker than your interior tile. They're 3/4 of an inch thick, frost resistant. You're going to hear us say this over and over and over. They're never going to stain, scratch, or fade, so they're going to hold up against UV rays. So I like to say it's a product that's on steroids compared to anything else out there in the industry. And then they also have high breaking loads up to over 2,000 pounds. Pretty much porcelain pavers are a excellent solution for your outdoor deck amenity. Some of the key features also, types of installation, what type of weights are suitable for your project. These are only under 10 pounds per square foot. We want to try to, get the aesthetic for the atmosphere that you're trying to achieve. And then we also have to calculate in dead load, pedestrian load, and then one of the most important aspects that Chris mentioned before, wind conditions. That's probably one of the, besides safety concern, wind conditions is also something that we need to be concerned about. Again, this is utilizing an outdoor space that normally in the past wasn't really concerned about, that people would just kind of write it off. But now we're seeing, between multi-living homes or commercial aspects, schools, or government projects, where they can take these rooftop applications, not only make them more of a green environment, but you can also use it for, outdoor healthy living as well, where you can, utilize these for, if it's a commercial aspect, maybe it's a lunch break atmosphere, maybe it's a meeting place, or just an atmosphere that people can go outside and just, get away from, their daily work life for a hot second and, kind of be out there with nature again. With using porcelain, it's a little bit more of an attractive finish. We can achieve many different looks, which we'll get into that in a moment. But then also there's some energy saving costs involved here as well. So, we do have SRI values that can help reduce the solar reflex index, and we have the RI values as well. For using these, new adapted areas, this could possibly increase revenue for potential clients if it's a commercial aspect, where you're not utilizing this roof, where maybe it's just, you just have all the utilities out there now, and it's just, with piping, drainage, and whatnot. So now you can actually take this area and use it and increase that revenue. So we can get into that more appropriately in a second. And then one of the more concerning things, your waterproofing layers, you want to make sure that those stay intact, and we have solutions for those as well. So here's some elevated systems that out there in the market. You have your fixed pedestals, you have your adjustable pedestals that are self-leveling, you have your aluminum rail systems, and then you have a polypropylene tray systems that are out there that either they're fit in between joists, or you can have them on pedestals as well. So there's a couple different solutions there. Some of the elements out there, this is going to, pre-existing. You want to make sure that the deck space is clear, of any kind of debris. You want to make sure your waterproofing membrane is intact. Your drainage is definitely a concern, because this is going to be standing over it. You want to make sure that your drains are sloped in the right direction. If they're going up against a parapet wall, or if they're in the center, you want to make sure those are sloped correctly and you get proper drainage. And then one of the more important things that you're going to need a perimeter containment to keep this system intact, and this way you can not have any lateral shifting. Some of the components, yes, you're going to have your pedestals and shims that are going to help with your slope. Your porcelain safety backing, we'll get into that in a moment, and of course, wind uplift. So here's a picture of where I am up here. I'm in New York. Nice winter, gloomy day, but this is your typical rooftop that normally people see that's not utilized. I don't recommend leaving a ladder out there year round, but you can see you have your air ducts, you have your irrigation lines or, electrical lines or what have you. So there's a lot of different aspects in here that you can take this area, reinvent it into an outdoor living space or commercial atmosphere, where if you want to have it as a break area or even just a commercial atmosphere where it's like we've done it where they've had concerts on roofs and so on. So there's so many different aspects that you can entertain with utilizing rooftop that you haven't done before. Your pedestal functions, yes, these are going to act as a drainage. It's going to be considered as like a permeable system. Therefore, you want to make sure all your drains are located in the right, right areas where the roof is sloped towards them, not away. Then you also want to provide, this also will provide your heights for any kind of irrigation. So if you have any, softscapes that are on the roof, flower beds, trees, whatnot. So now you can run all your irrigation lines underneath there so they're hidden. And if there's any future issues, these are easily accessible by pulling up the paver, and getting to that. So if you need to get to that drain, say if it's clogged for some reason, these are accessible. You can lift them up, fix the issue, put them right back down, and not have any problems going forward. So, and we can also be LEED compliant. So if you have a project that is, that it's contention for LEED, let us know. We can get you that information and we'll go from there. Again, types of pedestals, we have the fixed and adjustable. So these are your fixed pedestal heights. So you can range from anything from a 1/16 to 3/4 of an inch. These can be double stacked to increase that height. You will need a slope connector because of, depending on the slope of your roof. So these are fixed, very popular, very easy to work with. If you have, minimum heights, but if you're going with something a little bit greater in heights, we would recommend using an adjustable pedestal. These range in, just over 1 inch to, 39 inches, where your fixed heads, the heads are completely fixed. You'll need a slope corrector, to, follow that roof line. But one of the more popular ones that we're seeing nowadays is our self-leveling. So with the self-leveling, that acts like almost like a ball joint where it just sits there and it rotates. So your contractor, when installing this, it's much easier for them to install this and not have to worry about shimming this, or even as yourself designing this project, you don't have to worry about a contractor being like, all right, I need a little bit of a, I need to shim it here. And we've seen where they've used, just about anything from wood to cardboard or anything else to kind of shim that up. Not the proper installation, but we've seen it, and where the self-leveling actually fixes a lot of those issues. And that will actually increase the production time, the installation time, and for these guys getting on and off the job a little bit quicker. So that does help with the self-leveling. So with porcelain pavers, there's hundreds of different colors ranging from, natural stones to your marbles, your slates, your granites, to your woods, whether it's reclaimed or what have you. But now we're even seeing more and more popularity in our concrete paver looks. So again, keep in mind, no matter what project you have that you're trying to achieve, we can mimic the look in porcelain. So again, as I mentioned before, with porcelain, they don't stain, scratch, or fade. Very easy to clean. They hold up against any kind of de-icing salts, resistance acid. You can actually put muriatic acid on these. You're not going to scorch the paver whatsoever. The only acid that you can't use is hydrofluoric acid. And let's be honest, if you can get your hands on that, you have more issues with the government. So let's not even talk about that. But again, these are going to be slip resistant, no efflorescence whatsoever, because you don't have any cementitious products in this. You have the SRI values where they're cooler to the touch, and they pass all the freeze thaw cycles. Compressive strength 3,000 pounds, and probably one of the more important things, it's no sealers are required. So porcelain pavers have a 50 to 70 year life cycle. So with minimal maintenance, like cleaning your car, they just, you can power wash them, easy to clean, because they're resistant to any kind of mold, algae, or anything else like that. So we porcelain pavers, meets and exceed all the ASTM standards from absorption, your braking strength, chemical resistance, freeze-thaw cycles, flexural strength, your skid resistance, and your dynamic coefficient of friction. So with porcelain pavers, the absorption rate, is 0.05, where concrete pavers are 0.5, or even natural stones can be even higher than that. Porcelain pavers start at 0.05, and we've seen them up to 0.01, so they're virtually impenetrable. They're very lightweight, so just under 10 pounds per square foot. So with a 24 by 24 3/4 inch, you're under 38 pounds or 39 pounds per piece, I should say. They're fire resistant, so these are fired in a kiln over 2,000 degrees, so they are going to be fireproof. So you don't have to worry about that melting on a rooftop, any harmful toxin smells or anything like that. So you're in good shape if you need to be fire resistant. Resistant to stain. So with the low absorption rate, nothing's going to penetrate the surface, so that if there's any type of stain, it will just literally stay on the surface, and you can remove it with simple cleaners or other cleaning solutions. But just be known that you're not going to penetrate the surface of the paver, so you can get those cleaned. Resistant to chemical. So again, we do acid testing on these. They are resistant to every type of acid except for the hydrofluoric acid. And again, moving on to the UV protection. These are UV rated, so they're not going to fade due to other elements out there that are in there, due to natural stone or even concrete or wood. All these do require sealing. They will not hold up against UV rays over time. So compared to other products out there, this is virtually indestructible. And again, one of the things we do take seriously is safety. We do require anything over 1 inch in pedestal height to have, safety backing. If it's double mesh backing that's applied directly to the back of the paver using double mesh with epoxy, there's safety plates, there's polypropylene trays. So there's other solutions out there to help with that. And with that being said, it's not just that we want to add, more costs to the project. These are implemented so we can, it's like insurance. You don't want to ever use it, but when you have it, you thank God you do. And what this does is, if there's any kind of breakage on the job, if you were to use wood, natural stone, or even concrete, say if you're at an 8-inch height and pedestal, where say that paver breaks and someone falls through, you're going to get a sprain, maybe some minor cuts or bruises. Porcelain, if someone were to fall through, hopefully they don't. Porcelain is extremely sharp. It's razor sharp. So we take best practice by applying these safety backing. So this way, if that paver falls, it's just going to crack. It's going to hold up, and we'll demonstrate that in a second in a couple of videos. But it's there to keep that intact, and then you can go and replace that because they are easily removable. So here's a fall protection. Now you can see this is without the safety backing. That's just using a simple little 2-pound ball. Now we've done testing like this numerous times. Yes, if you drop something in the middle, it can break. Like I said, these are virtually indestructible, but the center of the pavers and it's hollow underneath, that is the weakest point. But when we do a safety backing, do the same testing. So you can see that paver cracked, but it's staying intact because of the backing plate that's applied to the back of the paver. And that's one of your stainless steel sheet metal backing. So again, this is there to keep the paver intact, and you can remove it easily. So with rooftops and porcelain paver applications, we're going to go into some design and installation process. So again, to perform it, a takeoff, here's some of the things that we'll need, basically, your paver size and, your series, color and size, shown on a diagram, like the diagram on the right. Basically, we want to see the drain locations with the slope towards it, your perimeter threshold, with the parapet wall, or if there's any kind of flower boxes or anything else like that, or if there's kitchens or what have you, all that should be located and designed in your takeoff, and then we can provide that for you. Basically, just providing the deck plans with all the information possible, and then we can provide a takeoff, which this is a example of a takeoff, and which is great about this is that we can color code the pedestal heights. So, the red would be lower to, your greens and yellows are going to be even higher. So this way, when a contractor gets on the job, not only can they order the quantities that they need, but you have all your measurements and quantities listed. And so they can actually be like, all right, we need 2 to 3 inches here, 6 to 8 for that. And so they can actually get crews going, make it a little bit easier to set up these pedestals and then keep that momentum going. So obviously get on and off that project. So with all this information, it just provides just for an easier takeoff, and we can get that accurately out to the contractor. So,
Hey, Ryan.
Yes, sir.
Can we jump back to that slide?
Absolutely.
So we've had a number of questions regarding loading and whatnot on this. A couple of points specific to those questions. This product is not designed to reinforce the roof or do anything like that or span over the top of the roof. The roof needs to have the loading capabilities to be able to put the load on top of it. So this is designed to take a roof that has a topography to promote drainage, use those various pedestals to bring you to a flat level surface, and then lay the tile in over the top. The system is self-contained for its performance values. So it'll span typical pedestrian traffic. Can you explain a little bit? We've had some questions about larger loads that may be placed on there, like a hot tub.
Okay.
And things like that, how that's determined and what you need to be able to determine if there's any issues with the system carrying it.
So I'll get into that in a moment because there are a couple of slides that show pedestal placements on pavers. So we can get into that in a moment. I think
perfect. I just wanted to make sure we had it coming up.
Absolutely.
And let you know that there was a lot of interest in that. So that works.
Excellent. So again, just going over water and air. So if you need if water or you're feeling like air is not getting there, they are floating base insulation bases. So this will act, the pedestal will sit on top of this, water will filter around under or through. So this way you don't have to worry about any kind of blockage. So this is something that's used not often, but if there's any major concerns, we do have that. So, and then here's the diagram we were talking about, where this is going to be your pedestal placement just for a 24 by 24, 24 by 48, 36 by 36, and so on. Oops, sorry. I think I'll get to that hot tub question in a second. So here's just your example of a rooftop and how contractors are installing these, making sure they're following their slope, 2% or greater, and basically just makes for easy application where they can take those pedestals, put them in the area where they already need be, if it's 2 to 3 inches or 6 to 4 inches, 4 to 6 inches, and they can work more efficiently. And sometimes a roofing, filter fabric might be needed on top if you have high dense foam underneath. So again, something else to keep in mind. I think this is where, no, one more. So again, these are fixed pedestals. So this way you can see the difference you're not as high, you're keeping it lower to the ground, so they can stack these and keep that, installation process going. So again, your Grabo tools, some of the tools and equipment that you're going to need, vacuum or lifters, that will just help lift them out, or you have a clamp. One of the things we do recommend is a dustless saw with a vacuum, just to keep dust down, especially if you're on a rooftop. Porcelain doesn't generate that much dust when cutting, but it does generate some. So just kind of keep the peace with the neighbors. We do recommend a saw with a vacuum. Now, here's where we're going to get into more of your questions regarding loads and so on. So I think it'd be a little bit more easier to explain in this diagram and the next one. So this is your pedestal placement around the perimeter. If you do have a small little cut piece, maybe it's a 2-inch by 2-inch piece, you will need a pedestal for that area just for itself. And we would recommend gluing that piece to the top of the pedestal. So for, dead loads such as hot tubs, or say you have kitchens, flower boxes, anything that's going to be, have a heavy load to it, we will require more pedestals underneath that area just to help to distribute that load throughout the roof and throughout the paver as well. So again, not that this diagram shows a good portion of it, but again, you're going to need more for that. For instance, if you have a flower box where maybe it's on wheels, and we would recommend, if you want to put it on wheels so you can move it to access and clean behind it, or maybe there's some drainage underneath there that you might need to get to. We've seen planter boxes on wheels, so, they can move it at will. We would just recommend those wheels being sort of like a roller blade. Anyone still into doing that? I don't know if that's still popular, but it's that, soft but hard rubber. So this way it will roll easier and not crack the paver. And then you can move those. We would also recommend using additional pedestals in that surrounding area if you were to roll that out or move it. So anywhere you're going to have dead loads or heavy loads like that, we would require additional pedestals for those areas. You can even, notate that on your plan. So this way, when it comes down to do, providing engineers to do takeoffs, we can plan for that accordingly as well. And again, here's a, radius. This will require additional pedestals just because it's a radius aspect. And anytime you have a, cut small piece, you would need to glue that to a pedestal on itself. Excuse me. And then basically, in and around draining areas, that may require some additional pedestals, as seen in the diagram. I believe this one's down in your neck of the woods, down in Florida. Here's a project up in New York. So you can see the aesthetics. So here, if some of these flower boxes and so on would need to be moved, yes, you could do that. Or, if they're going to stay stationary, just add a couple pedestals underneath that. Or here you have the kitchen. Obviously, that area would require additional pedestals just because of the amount of load capacity on that, just to safeguard it. But if you're using chairs or anything else that's going to be lightweight, you're fine. Do we have any additional questions? So rooftops.
Yeah, we've got
yes.
a boatload.
Oh, perfect.
Okay, so we've had some questions pop up specific to Miami-Dade. This product has not gone through formal Miami-Dade testing. We can qualify through engineering review and submittal, and we have done that on a number of projects. The Miami-Dade question is such a broad one, and it's hard for us to do Miami-Dade testing because we have to look at the specific system with the structure of the roof and how it goes from the roof up and the waterproofing and deformation and whatnot. A better strategy for us has been to submit it on a job-by-job basis because we cannot do Miami-Dade that covers every possible circumstance. So that being said, when you have something that you want to look at considering Miami-Dade, you have to get a hold of us, and we look at, first, we're going to look at the wind uplift, the proximity, the wind uplift requirements, proximity to shore. The zone is obviously there, the parapet condition and the orientation of the building to the anticipated wind zones. So there's no easy answer that it's going to qualify. I will say this, and this relates to the loading and the things that Ryan's already talked about. We do this at very early design development, because we can either put us in a good position to move forward before you make a huge effort and tie a lot of and invest in a system like this and the design part of it, or we can rule us out. The other thing that we ran into a lot with Ryan is adhesive questions, as far as, how does that work in terms of adhering it down? What are your experiences with adhesive? Have you done very much with that?
So adhesive being, if you're looking at a small little piece or just adhering it to the roof itself, clarify a little more on that for me.
Essentially, what we see down here a lot is when they have a roof that's not relying on topography for drainage, where they don't have steep slopes and they have a drainage system that's fairly flat, we will see this product sometimes adhered. And most of the time at Miami-Dade, the adhesion comes down to the success or failure of the adhesive and how that's been tested. So that's where we run into it in terms of putting adhesive on there. I can't give you anyone an honest answer on it until we look at what the substrate is.
Yes.
For the waterproofing, because how it interacts with that and how the chemicals all work is another dynamic we have to look at. We can look at a number of number of waterproofings that had an approved adhesive with it that's rated to a certain pound pressure of uplift, and we can plug into the system that way. So it's not that we're avoiding your questions, we're just sort of dancing around them because there's so many variables that affect the answer.
No, absolutely. So, I wish there was one answer for everybody, but every single rooftop project that I've worked on, and there's been countless, every single one of them has been different. So there's different, everything just, you think they would all be similar, but no, each one is different from the following. So either it's, rain or wind, or just getting proper drainage, or just trying to figure out how to adhere to the roof like this, or how to, if you need a complete wind lockdown system, how can we secure, some of the pedestals may be required to be connected to the roof. Maybe there's other solutions that we can work on that, by installing girts and just having, to help with the tie downs. Again, every single rooftop project is different from one another. So we're here to help you guys and to help facilitate your project. So whatever kind of concerns you have, feel free to reach out to any of us, and we will get you the proper answer.
We can usually bring this to a head in a half-hour conversation and then follow up with anyone we need on our side. So we can, before you get too far in your design development, there's been a lot of other questions regarding water and freeze thaw. Mm-hmm. And just to address that, the low absorption is the whole key to this product. Low absorption determines a number of different things. That's driven by density of the product. So low absorption is going to bring in very little water because there's not a lot of space for it to go into, and it's an extremely hard product. It's baked to vitrification. So if you take sand and bake it to vitrification, it makes glass. This product performs very similar to that with clays and shales, where it's going to bake to vitrification and it creates a very low absorption rate. Where that has value is freeze thaw, water goes in, it stays there, and then it freezes, it expands, and breaks things apart. You're not going to get water that goes into it. When we talk about the stain resistance and things like that, when water comes in, it brings dirt with it, the water evaporates, it leaves the dirt behind. Low absorption rate, you have very little discoloration with this product. So the real linchpin to all the performance values of this is that low absorption rate. Now, in terms of where you have heaving or any ice or anything that generates underneath the product, if you're adhering it in a freeze thaw cycle, you do have potential where you might have water underneath that could cause it to pop. In terms of pedestals and things like that, it's going to be really difficult to have that happen. These products do have a heat island effect. So they're going to retain heat and warmth, especially from the sun. They're going to have great exposure to the sun. So I typically don't see a lot of things with any kind of heating happening in cold weather climates. Ryan, you're based in New York. You could probably answer that even better.
No, absolutely. I mean, I can even share photos of a project that I was on last year where there was snow all over the patio where they, shoveled it off to the edges, and that's going to melt and go right down into the, the bottom. So even if water, I mean, water's not, you shouldn't have your roof, if you were to remove the system itself, water shouldn't be sitting on the roof. So if it does melt or if you get rain, it's going to, filter right back down into the drain. So that's going to avoid your heaving. So that's your freeze thaw. So
now he's, oh, go ahead.
No. So maybe I'm misunderstanding. So
no. You're perfectly fine. Exactly what you said. I was going to go on to another subject. I didn't know you were.
Oh, okay. So yeah. So
no, you nailed that.
Yeah. So your freeze thaw is going to, it's, if everything's pitched correctly with your slopes, freeze thaw is not relevant at all, because if it melts, it's just going to go right down to the drain, or even if it's blocked by something, you're not going to have any issues whatsoever, because you still have plenty of height.
Per code on that roof, it's typically designed with a maximum of 1/4 inch per foot slope. The way that the pedestals are designed, you can either have a leveler underneath it to absorb that 1/4 inch if you have a fixed head. If you have the gimbal head, that's made to absorb the 1/4 inch per foot. So then it's just a matter of them getting the correct heights, which the design denotes with all the different colors or different heights, and they can lay it out so they come up with that nice flat surface on top. So all we're doing is putting a flat surface on there. You have clear ventilation and clear drainage in between the tiles. They're rectified, so you have really crisp, clean lines, which is a nice aesthetic on it. The last thing before I let him get started, we had a number of questions about fixing the pedestals onto the roof. They are not screwed down. They are sitting on top of your waterproofing typically. That's what makes wind load uplift such a difficult proposition in this, and why we have to navigate each job. There's not a catch-all anywhere in there. In terms of all the questions about how all the system ties together, he's about to get to all that. So we'll have some more things coming up here, and I'll try and jump on these questions with Cynthia in the background, but we'll let you get back at it. I think right now we're doing pretty good as far as time. So just keep plugging away.
Cool. So again, here's a great scenario. In this picture, you can see the porcelain pavers. They have some turf grass off to the right. You have your flower boxes, but then, you have some seating area that's also designed with porcelain pavers, which is the wood look. So not only can you use these horizontally, you can also use them vertically as well. So they can be glued to, outdoor kitchens or seating areas, or even if you're doing ventilated facades or something else with other aesthetics, just be known that, yeah, you can mix and match porcelain within itself. And that's it. So again, I know there's a bunch of questions that we would love to enter, to get to, and basically just sum this up for you.
Yeah, I mean, when we're looking at it, as far as the system goes, the pedestals themselves are put there. So what you're looking at is you're trying to create a dynamic of a diaphragm. So if you think of, I always use the analogy of a car speaker when or a stereo speaker, where you see that large cone moving back and forth. The old fashioned ones, they don't even make them anymore like this, but they have that large cone that moves. When you have a wind incident, it's going to cause the whole thing to rise up as one, but the system is tied together, so it makes it settle back down in terms of the E-deck and all that. Do you have very much on the E-deck that you can show them, Ryan, as we go through this?
Yeah, hold on, I'm going to stop sharing for one moment.
So what you're looking at with this is, we want to, in Miami-Dade specifically, we have two big issues. We have to worry about wind uplift, but then we also have to worry about deformation after the incident. So deformation after the incident is how intact is it after it's finished? So that's why first of all, we risk a great deal if we put any penetrations in the roof. On the perimeter, there can be some edge tie downs for everything there, but essentially we want to make it as tight as possible on top and then lock the pieces together with a couple of different things, which Ryan is going to be bringing up here. But that gives you an idea as far as how the system works as one. So you get that diaphragm action where you have an incident, the whole thing will rise up a little bit, particularly in the middle. On a parapet, that wind comes off and it starts to tumble. And it typically tumbles and has its worst condition about 4 or 5 feet off of a 3-foot parapet. So when it comes in, it has that tumbling effect. It's going to want to draw everything up. You want it all tied together so you have relief from that pressure of everything rising up very subtly, but it comes back down. So that's really the dynamic that we run into with this. The big advantages with this, you cannot have, I see another question that popped up here from Surge in terms of prevent uplift at the perimeter. This is virtually an impossible system if you don't have a solid parapet in wind uplift conditions. Because if you have it set up where that wind can tuck directly underneath this, it's going to take everything right with it. The parapet itself is a protection that's built into it. There are, in terms of, Mark, I see your question there with the paver fastened to the pedestal. Essentially, that's what Ryan's going to bring up here real quick. He's going to talk a little bit about their EDIC system and some of their things they do to attach it down.
So forgive me, I'm just going to go through a bunch of these right in the beginning. So this is our EDEC system. It's an aluminum rail system. They come in 10-foot lengths. You can do modular patterns, different sizes. So basically, oops, sorry, I'm not sure if you can hear this, but here's our EDEC quick video on this. Obviously, you always want to make sure its surface is clean. And these are mutes, so you just want to make sure that acts as a barrier between the bottom of the pedestal and the roofing membrane, so this way you don't cause any issues.
When you look at this system and how it works, it's the same thing in terms of loading and how you absorb a load vertically. When you want to make it so it's not a point load, you want it to be repetitive members, and tying the beams together creates a repetitive member condition. So what happens is, in terms of uplift and change and rise, it's tying them all together. You know, the strength of the pack is the wolf, not, you know, vice versa. You got to have a number of different things. You know, that's an old phrase from football. You know, the strength of the pack is the wolf. The strength of the wolf is the pack. You know, there's strength in numbers when you're carrying a load. That works with a load coming down on the top. It also works with a load being pushed up. So you can see those are the shims that are absorbing the natural drainage that's designed into the roof on these particular ones. And then you see those large rails are really going to give us that extra support and tie a system together. So now we're dealing with repetitive members, and that gives us strength in itself.
And good point. And with that, you know, once everything kind of clips in together, and once you get this portion of it secured, you get your pitches, your slopes, and so on, you get it corrected. Now it's just coming in and laying your tile, which is probably one of the more concerning things with time consuming when just using your traditional pedestals. So you know, usually it's a 2-guy situation. You come in, one fixes it. Okay, boom, you got to get your heights. Okay, you got to come back, adjust it. So with the aluminum rails, once you get all your pitches and slopes, you know, done, now you just come in and, you know, set the tile, and it makes it very easy. And you know, with these aluminum rails, they do have tracks in there, so this way you can import the spacers. Very easy to use. They just, you know, spin and click. That's it, done. So now you can just keep moving forward. So, and those same channels, you would actually reverse the direction of the porcelain paver. Instead of going, you know, crisscross, it would go horizontal with laterally with the rails, and that would act as a wind lockdown channel. So we call which are H clips, which I could show you in a second, but I know we're getting a little time consuming. You know, let me just I'm just going to speed up here a little bit because I don't want to run out of time on you guys. So you can see how, you can do a little step ups, makes it easy. Oops. Oh, my apologies. But I do want to get to another portion of it. So if you do have some steps, we can do that. If you have some lateral stops, you can put those in there. My apologies. Hold on. Let me see if I can find that one video for you real quick.
No, you're doing fine. Wendy, what time are we finished up at? 11?
Let's see, for this session, you've got 11:55. So yeah, you're done. This one's supposed to be done now. But the next one, starts at 12:05. So if you want to take a few minutes.
Well, here's the bottom line with wind uplift. There are capabilities that we can do things with wind uplift, and we could go down this rabbit hole and really have a conversation for probably 3 or 4 hours, if I'm being honest. And I don't know that that is really a positive way to go, because it's much better when we're looking at specific conditions rather than throwing out hypotheticals. The best way to qualify if you want to do something on a rooftop, first of all, you have 3 resources with myself. With myself, Ryan, and Cynthia, that we can deal with specific issues with you all. And if we look at it, typically when you're doing anything that's in a wind lift area, we can do specific code requirements from your code inspector, and we can go through those things, and we can deal with the issues and then tell you where it plugs in and what ratings we can achieve and what systems will achieve that, and see if they fit the aesthetic you want. Now, if you look, I'll let Ryan jump in here. I know what he's got up here, so I'll let him go ahead and show you.
So again, thank you very much. So again, here's some of the components that we have in here. You have your rails, you have your C clips and H clips, and you can see in that channel, that's your lateral restraint right there. But we can use that same channel when laying the pavers on top of that. We have kerfs that we can do on 2 long sides of the paver, and they lay on top, and then that H clip slides right inside. If you see on the top right, and I believe, give me a second. And here's all our testing that we have to go along with that. Again, we would have to refer to the Miami-Dade. So here's those kerfs. They run long ways. And then you can see in this photograph right here how it demonstrates how, those clips will, once the pedestals, those would have to be for a complete wind lockdown. I refer to as like a watch. You can have a waterproof or water resistant. So to be water resistant, okay, which would be wind resistant. So you can lay the pedestals right on the roof, your rails, your H clips, and you can tie that down to the system. But if you need a complete wind lockdown, the pedestals would have to be secured to the roof some sort of way. So again, every project's a little different. I know everyone's sitting there saying right now, no, I don't want to, puncture the roofing membrane or anything else like that. But we can work with you. There are solutions on that. So just to show you, here's a little cross detail on how that clip slides right in. And, now you have a uniform system where it's going to, everything works together as a pack, kind of keep that from, lifting up.
Okay. I'll tell you what, let's go ahead and wrap it there. Ryan, I'm going to be on the next one here. Ryan and Cynthia will be able to wrap up these questions that are still kicking around in Q&A. Hopefully this is a good discussion to show you that there are some options with this product on a rooftop application. We can't give you carte blanche and say every application will work, but it's definitely worth pursuing. A phone call never hurts anything, and we can run through and see how it fits. It's a fantastic aesthetic. To give you an idea, we've done probably over 100 roof pedestals in Central Florida with these systems because the wind uplift is very, very friendly, obviously. On the coast, if I'm being honest, this is probably going to be, I think we got a fighting chance on 50% of the jobs on the coast. If you're right on top of the beach and you're 20 stories up, I don't think we're going to be able to do it because that's a pretty extreme condition. But give us a call. We'll be able to qualify whether we can or can't. Pedestal Systems, there's no one that's certified for that application for every circumstance. So beyond that, Ryan and Cynthia, they've been great partners for us. Thank you so much for the presentation. If you guys can hang out in the background, I appreciate it. Great job. You guys can hang out in the background and wrap up those questions, and then we're going to get started with the next one. I'll let Wendy tell you all the schedule, but we got Ariscraft with another one of our courses coming up here shortly.
Thank you, everyone.
Hold on, I saw one question come in. I just want to answer that. You know, how to prevent uplift around the perimeter. There you can use a perimeter ledger, which would be like a piece of angle, metal angle that would be secured to the roof, and it would be channeled in. So then that would go into the kerf of the paver. So I saw that question. We can send you some details on that. Just reach out to myself, Cynthia, or Chris, and be happy to get you that information. Thank you, guys.
Thanks. Great job.
Thank you, Ryan and Cynthia. All right, folks, this has been amazing. You guys are typing in some great questions, and they're going to go backstage and hopefully answer some of those backstage. So for you, our attendees, we are on a break. Call it a brain break. So you can have a minute to kind of disconnect and do what you need to do. Actually, stay logged in. Don't actually disconnect. And we're going to get our next presentation up and running and start back at 12:05.
Wendy, I think Matt is already here somewhere.
Okay. You want to go ahead and get your presentation up and running? And we'll still wait till
he's the one that would have to do it because it's his.
Yeah.
Yep. I shared it with her earlier, and I will share it again.
Hey, Matt.
Hey, Chris, how are you, man?
Fantastic.
Where'd my share button go? I haven't used Zoom in 2 years. I've been using Teams all the time. Recording.
Don't touch anything but share.
Share was at the top in the middle earlier when I was talking to Chris.
I'm in AI's office, so if you screw this up, they can come down and smack me. So you better make sure.
Oh, I'll do it on purpose now.
You might need to minimize a window or two. Sometimes it finds itself hidden.
Okay. It's open. View, speaker, gallery, hide self. Full screen. Leave. There it is in the middle. Dadgummit. Can you see it, Chris?
It's working on it.
It says there it is. It just popped up.
Okay.
You just got to go in presentation mode and you're good.
I see participants, pause. Oh, let's see.
Beautiful.
Matt, when we get started, I'll go ahead and do a quick introduction, then you run with it and I'll be in the background with Q&A. And then just pause a couple times so that, you know, if we need to have any discussion points, we can do that real quick.
Yep.
So yeah, let's give everybody a few minutes to do what they need to do. And then Chris, if you want to just keep an eye on the clock, you can start at 12:05.
Okey doke. And then we're 12:05 to what?
12:55. So this is a 50-minute.
Okay.
But again,
And
you're going to be going up against a lunch break, which is like 20 minutes. So I'm okay if you go over a few minutes if you need to. And then, of course, going backstage to finish answering any questions is an option.
Okay.
Ryan's typing away back there.
think I answered everyone's questions. Again, thank you very much. Have a great day. If there's anything else you need, just feel free to reach out to us. Enjoy your day.
Thanks,
Happy
Ryan.
holidays.
You too. See you, buddy. Okay, Matt, we got a clean slate when we get started. So.
Okay.
Okay, everybody, it's 12:04, so this is your 1-minute warning. We'll get started here in a minute, and then we can let her rip. That is quite a dramatic picture on that building, isn't it?
Isn't that cool?
It is very cool.
That is about less than 100 miles from Indiana Limestone's quarry. So you can imagine the politics of doing a public university in Indiana with Ariscraft.
That's one of Brian Moore's jobs then, right?
Yes. Yep. University of Southern Indiana's Aquatic Center.
That's quite a building.
Yeah.
Okay, everyone, it's 12:05, and I need to keep you happy, so we're going to go ahead and get started. Again, this is Chris Bettinger with Oldcastle Coastal. This is the second of our 3 hours. We only have people that are good partners that do these things. Mirage is a fantastic partner with us. We're glad to have them previously. A lot of good questions, so we appreciate that. I'll be handling Q&A questions in the background. We'll have a couple spots where Matt Mara, our presenter from Ariscraft, will pause and we can jump in. He's got a ton of things to show you, some really dramatic products or projects. This is usually a pretty fun presentation. This is a huge partner of us in the state of Florida and beyond. So we really value this relationship, and I'm thrilled to death Matt could do this. So Matt, I'm going to hand it off to you, and let's go ahead and get started.
Good deal. Thanks, Chris. Appreciate it. Okay, my name is Matt Mara. I'm with Ariscraft. Ariscraft is a stone manufacturer, and we cover pretty much all of North America. And you're going to learn about both calcium silicate stone today, as well as our company. Ariscraft is a division of General Shale Brick, North America's largest brick manufacturer, also represented in Florida by Oldcastle and several other locations. And we're the North America division of Wienerberger, the world's largest brick manufacturer. At Ariscraft, we've been around since 1948. We quarry natural stone. We make cast stone products, ASTM 1364. We make calcium silicate stone products, ASTM C73. We do this in thin stone applications as well as full bed applications. We do this in rain screen wall systems. We have a continuous insulation panel. Under the General Shale brand, we make ASTM C90 concrete products, and we have clay brick plants across North America and the world. I say this because at Ariscraft, we like to help architects with wall systems. And quite often, the difficult part an architect has to make in his decision is what wall system you use in designing a building. And the final masonry product or thin stone product or something like that is just the final decision. So we like to help you with wall systems as well as stone. Some of our brand names and today's learning objectives, we're going to compare natural stone to concrete stone to calcium silicate stone. We're going to talk about best design practices when designing for masonry walls. We'll talk about versatility of stone cladding. We'll dive into thin cladding systems, and we'll touch on sustainability at the end. If we look at how Mother Nature makes stone, picture of North America here on the right, Geology 101, there are 3 types of natural stone. In Ariscraft, we like to call ourselves the 4th natural stone, and I'll show you why we're arrogant enough to say something like that. We look at the yellow across North America. Sedimentary stone is limestone, sandstone, travertine, soapstone, shown in the yellow. You're familiar with Indiana limestone, Texas limestone, Alabama limestone, Kansas limestone is all of those areas. Those are type 1, type 2, and type 3 stone, type 1 and type 2 limestones. Next is metamorphic stone, which is class 3 limestone in the green, a little bit in the mid-Atlantic, but mainly quarried north of the Great Lakes, and as well as marble. And igneous stone is in the red, nice swath of it through the mid-Atlantic area. A lot out west is quarried, that's granite and quartz. And last is manufactured stone in the form of calcium silica stone. It's been around for 150 years, using Mother Nature's recipe and just doing it in a plant. So how does Mother Nature make stone? Nature makes stone through 100 million year process of starts with erosion, erosion of sand and minerals deposited into a river or lake bed. More erosion fills in the lake or river and puts pressure on top of that deposited sand and minerals, and steam and heat from the earth below over 100 million years forms the stone to a bedrock in the earth. We look at a quarry from above. We first start by removing overburden to get to the stone. A very high-tech way of taking the stone out of the ground, chainsaw on wheels. And you notice the guy in the upper left-hand corner for scale, large cubes of stone taken up to the finishing house. And our limitations are pretty much the size of our splitters and our saws. We can saw panels up to 30 inches by 72 inches. And we can split stone into 2 foot by 4 foot face units. Out of this particular quarry, we get 2 colors. We get a sepia, which is a khaki with a light gray vein, and we get blue gray, which is, I can only describe it as it's what Jerry Jones put on Dallas Cowboy Stadium. It is truly a blue gray stone. Type 3 limestone is typically used in applications where you need some resistance to freeze thaw as well as wear and tear, like stair treads, pavers, and things like that. Can be used up north where we get lots of freeze thaw in areas like Washington, D.C. There on the left is a fallen police officer's fountain outside of the old Smithsonian building. On the right are some water features up in Canada. No fear of freeze thaw when you're dealing with a type 3 limestone. We cut thin enough to cut it into tile. It's dense enough to take a polish. Don't have to worry about salts from the ocean or chlorine chemicals from a pool. We can take it thin, cut it thin, take it inside. Maybe you've got a building that's got full bed stone outside. You can take it inside. Again, you can cut it thin. And the denser the stone, the thinner you can cut it, is really how it comes down to. You can do it in panels. Quarried stone can be cut into panels and anchored. And then, of course, you can always cut it into small enough units that a mason can set them. And because these are quarried and cut, our limitations are kind of pretty much your imagination. I was recently asked by an architect for a 3 foot long paver. And of course, you can't do that in clay. That's too big. Concrete, again, poses a limitation on the size of the concrete press. But in stone, we could cut it. And, my only question to the architect was, well, other than 3 feet, how wide do you want it? He wanted it a 4-inch wide paver, 2.5 inches thick. And that was fine. So it's, again, just we typically, most of our stone conversations for quarried stone starts out with a question from an architect asking if we can do something. And again, our limitations are just the size of our saw blades and splitters. You visit our website at Ariscraft. We show just some basics of stone. Most of our conversations for commercial stone start with an architect having an idea of something they want to do. So why has natural stone been used for centuries? Well, we look at it, it's typically a regional material. It's durable, lasts forever. Long history of performance on some of the world's oldest buildings. It's beautiful for facades, interiors, and hardscaping. Very versatile for shapes and profiles and things. And of course, it can be used across all types of design. When we leave natural stone and we go into man-made stone, there's 2 types of full bed masonry units. Those are ASTM C73 calcium silicate masonry units, which Ariscraft is the only ones in North America that make. So it gets hard when we're writing a spec, but we always help architects with state specifications when you're trying to get around that and leave the door open for other people to participate. This material has been around since 1866. It was brought to North America in 1948 by the guy who started Ariscraft. And then it's concrete masonry units, ASTM 90 units, and that encompasses concrete stone, concrete block, concrete brick, and all the concrete masonry units. We look at how a concrete masonry unit is made. We start with sand or gravel. Think about it. If we've got a fine finished concrete stone, we're going to use more sand, less gravel. Split face block, more gravel, less sand. Portland cement is going to be our binder. Water, iron oxide pigments, additives like integral water repellent and color guard to keep it from fading. And that gives us a finished architectural masonry unit. We look at a calcium silicate stone unit. We have two plants in North America, one in Canada, Cambridge, Ontario, where we have a brown sand, and one in Georgia, where we have a white sand. So we have two different color palettes. This is the Canadian sand. We add unhydrated natural lime to that. That's going to be our binder after it goes to the autoclave and hydrates, and then iron oxide pigments. And from there, we don't have any other surface treatments, anything else like that, other than textures that we put on. You'll see in a second, but that's all we put in there. Pretty much the same ingredients that Mother Nature puts in natural stone. We compare a calcium silicate stone to a class 2 limestone, the Canadian limestone, to a concrete masonry unit. Compressive strength has to be 4,000 PSI for type 2 limestone. Has to be 8,500 PSI for an ASTMC 73 calcium silicate stone. And the minimum for concrete stone is 3,500 PSI. Now, concrete stone is we're just putting the minimum amount of Portland cement into a concrete masonry unit to get it to meet the 3,500 PSI, because we don't want to drive our cost up. So that's not a negative thing. And if you put in more Portland cement, it changes the properties a little bit. So it's something we have to be concerned with. Absorption is for type 2 limestone is 7.5%. For concrete masonry is 6%, and for calcium silicate stone is 8.5%. And then the density is fairly similar, 105 up to 135 pounds per cubic foot. We look at how we make a calcium silicate unit. I'm sorry, I left the volume on, so you'll get to hear the plant. This is a 1 million PSI press. That is the body. We're making a stone every 6 to 7 seconds. There's one that broke. You think marketing team could get a video without that? If we were standing next to this press in Fort Valley, Georgia, and we reach out to grab the edge of that stone, you can still crumble the edge of that stone. Just because it's been pressed with a 1 million PSI pressure of pounds per square inch of pressure, it's not a solid unit yet. We're just forming it kind of like you would a sandcastle at the beach, but it's dense enough that we can pick it up and put it onto an autoclave cart. And we'll pick up 6 of these at a time. These are 12 by 24 inch units. They weigh about 100 pounds a piece when they're full bed. And from there, they're going to an autoclave. In the autoclave is just a big pressure tube. This is our kill, if you will. We're going to load autoclave carts and full of stone, put them into the autoclave, seal it, put it under pressure, take it up to 300 degrees Fahrenheit, add pressure through with steam and heat, and in 8 to 10 hours, we're going to get a solid unit. Now, remember, Mother Nature took 100 million years under pressure to form natural stone. We're going to cut a little time off of that. And in the process here, we're going to get a solid unit. From there, it's going to go into what we call the holding area. We just happen to be showing all white the day that this was taken, but this shows all the units waiting to go into the finishing building. The finishing building, we're going to add finishes and stuff like that. But what you're seeing here are what we call chiclets. They're ready to go. Now, in this room, we've probably got some tans and whites and things like that. These could structurally go into building right now on the wall. This was a concrete product. We need to wait another 7 days to meet code, but these are ready to go. Now we just got to finish them. So, sorry, I knew that was coming up. So if you specified smooth, this is a diamond honed finish stone. This guy is basically making sure there's no burrs on the edge, and he's inspecting them for imperfections. We don't want any cracks shipped to the job site and stuff like that. And you notice they're wet is because we do a wet honing. Now, this isn't when we diamond hone these aren't dense enough to take a polish. So it's just going to be a fine sugar cube finish like type 2 limestone. Next, we're going to, if you specify rocked, we still rock by hand. Why do we rock by hand? Well, we rock by hand because we want a nice, unique stone each time. Now, normally in the plant, there are 6 guys doing this job. We want a nice big belly on the stone, nice proud stone from the wall. He's setting his chisel on a guide to make sure that we maintain a 3 5/8 inch bed here for a full stone unit. On the back side, there would normally be 3 guys on each side of the sign. We just got one. He is taking his chisel and cleaning up the back side of the stone. Now, these guys don't do this 8 hours a day. They actually rotate around the conveyor belt here, changing positions. They also rotate at the plant throughout the day. So these guys do this for about 2 hours. And no, they're not going to go to the gym afterwards because they don't need a workout. People always ask us, what do you do with all that wasted stone? Well, actually, we grind it up, we bag it, and it ends up landscaping all over the Southeast United States. So that's what we call architectural stone. Like in natural stone, we start with 3 standard sizes, 11 5/8 by 23 5/8, 3 5/8 inch bed depth, 7 5/8 by 23 5/8 by 3 5/8 inch bed depth, and 3 5/8 by 23 5/8 by 3 5/8 inch bed depth. Now, those are our 3 standard size units. However, we have a large saw house. So when somebody's specifying something different, we can actually cut these blanks, these units into different sizes. I did a school in Loxley, Alabama 2 years ago, and the 1 foot by 2 foot unit there on the left, we actually ripped that in half into a 6 by 24 and into 12 by 12s to help the architect with the pattern he was trying to get in his masonry wall. Here's our color palette across the 2 plants. The only premium colors, upper left is a charcoal gray, and middle row, second from the left, is a premium red. And they're only premium because of the amount of pigment we have to put into the stone to get that color. At Ariscraft, we're kind of unique. 50% of what we do is custom colors. And so if you've got a project where you're trying to do something unique and you want a custom color, we're typically the folks people call. We will do typically no upcharge if there's no premium pigments in a stone for any project over 8,000 square feet. What's 8,000 square feet? 8,000 square feet is typically about 1/4 of an elementary school. I've done some large houses where we've made some custom colors for a client, stuff like that. And so we're asked to do custom colors all the time. Why would you want a custom color? Example, we did a courthouse. City Hall in Texas, where the old courthouse was over 100 years old, had a red limestone on it. They couldn't get any more. And we made them a red stone to match their red limestone. Hospital campus in Charlotte, North Carolina, college campus, the hospital campus wanted its own color. And so we developed a color just for their college, for their campus. We make custom colors for over 150 colleges and universities across the United States when they can't get to their natural stone anymore, or it's too expensive to core it. Here's an example of our rock texture. I like to show these slides because it shows that there's no 2 stones in the wall that match. Because we've got 6 different guys rocking these. These look like stone did 120 years ago when guys were rocking them by hand in the field. This is an example of a custom blended job. We took a gray from 2 different grays in 3 different sizes, 4s, 8s, and 12s, and blended them together in this wall to match a historic church in Charlotte, North Carolina. If you are specifying limestone on a campus and you're trying to match old limestone, we make some colors like this one called birch bark, which looks like old limestone. This is very popular from Chicago all the way over to New York. We actually make another color darker than this that looks like really dirty limestone. And so we're always doing colors to help folks out. This just happens to be a color that stayed because we have done it so much from Chicago to New York City. So Ariscraft, as I mentioned, has been around since 1948, well past 70 years. We figure we're well past 500 million square feet of stone in the wall, and we have a lifetime warranty. The lifetime warranty is not your lifetime or my lifetime, it's the lifetime of the building. And if the building has been designed correctly, we guarantee the stone for the life of the building. Now, how do we know it'll last that long? Well, Ariscraft's been around since 48, and we've still got buildings that we've done back in the day that are still up. And here's one of the examples. This happens to be our office in Cambridge, Ontario, built in 1950. The wall on the left, it has been outside since 1950 in Cambridge, Ontario weather. Wall on the right is the receptionist wall inside. And we make architects, when they visit us in Cambridge, stand on the front door and look at these 2 walls. They still match after 74 years. And so we typically don't get any color fade. Our challenge on color is to get past the mason on cleaning day. Now, we have a proprietary cleaner for our full bed and thin stone, so that when we do have to have it cleaned, we can recommend a cleaner and an applicator and everything else. We'll also do job site training to make sure the guys get it right on their cleaning. Oldest project we've done in the state of Florida. This happens to be a job we did in Jacksonville in 1996. I took this picture in the summer of 2022. 28 years in the Florida sun, and the stone is still the same color as the day it went in. We were in Jacksonville inspecting this building. There is a bullnose cast stone unit that we didn't make, but had we made it, it would do the same thing. It's gotten dirty. It needs to be cleaned. But the Renaissance calcium silicate masonry units in this building have not faded over 28 years. Lots of projects around the state of Florida. This happens to be one we're very proud of in Dania Beach. This is Dania Point Shopping Center. This architect, the developer asked the architect to do some research. They wanted something that would last a very, very long time with no maintenance. And the architect came back to the developer and told him to use either brick or Arriscraft stone to keep that look up. And so this happens to be Main Street in Dania Point Shopping Center, where the architect seems to have picked on one of every color we make each time they do a new section of the building. Here's some more from around that campus. Great place to take an architect for lunch to look at stone. So how does full bed masonry from Arriscraft or calcium silicate stain go on the wall? It goes on the wall just like a clay brick. Cavity wall system, commercial grade brick wall tie, no stone anchors required. Mason's going to lay it up with Portland cement lime type in mortar, and same movement following up brick. Now, as architects design buildings out of full bed masonry or thin, we have to be aware of as we put different materials in the wall together, how they'll move with each other. When you're combining a calcium silicate stone or natural stone in the wall with a clay brick, which is done quite often, it's a fairly simple wall. We're going to follow the Brick Industry Association's tech notes for movement joints and detailing. And in the 66-foot long wall, we would have two 25-foot maximum spans of stone and brick, and within 10 feet of the corners. And that would be it. Commercial grade wall ties, cavity wall, that's it. If your general contractor comes to you and says, oh, we'd like to do a substitution, offer an alternate, and these are the changes you would have to make. So as we look at this wall now with concrete masonry units in it, we're now going to have to include the National Concrete Masonry Association tech notes for movement. And so since clay brick expands over the life of the building and concrete masonry units shrink, we would want a bond break or slit plane above and below our accent band. That's the orange banding. We would also want it on top of between the top of the wainscot and the brick. So the clay brick can't bond with the concrete masonry units. And we're going to put in an additional expansion joint to follow the NCMA's maximum of 20 feet of between expansion joints. And that is so we're going to have 3 18s and 2 6s there for that. Down in the wainscot, the turquoise blue is going to be joint reinforcement, maximum of 16 inches. So on a 12-inch stone every course, 8-inch stone every other course. And then the additional purple lines are the control joints. We want to control the cracking hard. So it's going to be we're going to follow NCMA's tech notes on a additional control joints in that wainscot. So it's a 4-foot wainscot. So every 6 feet, 1.5 times the height of the wall, we would have to have a control joint. And if we don't do it, Mother Nature will put them in for us. Here is an example of a hotel where they made a switch from calcium silicate stone to a concrete masonry unit, and they didn't change the design of the wall, and this wall cracked. This is a wainscot on a grocery store. Salesman's put his business card in every crack. This wall should have been designed. It's a 1-foot tall stone, so about every 4.5 feet there should have been a control joint, and they designed it like the design was for the calcium silicate stone. And they have a crack every 3 or 4 feet. Mother Nature put a crack in. And last, this is This is kind of a sad project. This was a university project where somebody came in and said, oh, you can make the substitution because we're just like calcium silicate stone. And this is an ashlar pattern stone. So if you're laying up a concrete masonry unit, you're going to require continuous joint reinforcement. And they didn't. And so this wall spider crack went everywhere. And it kind of bankrupted the firm because the firm could not get, the architectural firm couldn't get insurance after this wall cracked. And so be aware of when you're making substitutions, what the materials are. Go to somebody that has experience. If you're not using my product, I'm still going to tell you how to put a wall together. Same thing with Chris Bettinger and the team at Oldcastle. Now we've had a couple of questions. I'll take a pause here. Should I, Chris, to see who's, if there's questions?
The questions have been pretty simple that we've gone through. Actually, one just came up here. We'll do that one live. How does the stone repel or get cleaned off after it's been spray painted?
Well, that's the funniest thing of all, okay? If it's been spray painted, there is a chemical that will take stuff off. It's the only one we recommend. And I hate to say this is not a joke. It is called elephant snot. Yes, you can buy it on Amazon, but it is a chemical remover that that will take paint off of our stone. And every time
What's it called again?
Elephant snot. Can buy it on Amazon. Chris, I can't believe it. As long as you've been around the Aeroscraft, you've never heard that? That's the only one we recommend because it will do the least damage.
If I had heard that before, I definitely would have remembered elephants.
Yeah, I know you would. I know, yeah.
Obscure things I'm really good with.
Well, when I joined Aeroscraft 6 years ago, I thought I was being punked when they told me that. So I thought, okay, go ahead, Chris.
No, I was just going to say, one thing about this product is you can get such a dramatic look to it, and you can really get away from, what drives me crazy when you plug in a split face on these is you have the belly in and belly out, and you have all those different issues. Aeroscraft is named after the eris of a stone, that natural curve. And I don't think they'll ever get away with every piece looking different. And that really is a nice part about this. And it's through the body color. That's the only thing I'll add to what you've said up to this point. One more question before we get, does the wall mounted stone have an NOA, or do we need delegated engineer for the system? You are the perfect setup, man. He's got some stuff coming regarding NOAs. So we'll go ahead.
So full bed NOA is not required. It falls into the full bed masonry category. And we get to thin. Yes, we've got testing to get to. Yeah, we've met the NOA.
This is one of the few products that has it out there and isn't just relying on whatever the setting material is to rest on that for their AO or their NOA. So we'll let you get back at it right now. You're about 25 minutes out from the end, so I think you're doing pretty good.
Good deal. Thanks. Okay, let's see if I get back here. Okay, we'll take the same stone and cut your details, accent shapes and details. I love this picture right here. We have just got done honing a bullnose unit. So upper left-hand corner, you can see it's a two-tone unit, most likely our Oak Ridge color, which is a khaki, which is a tan, two shades striated together. And if you want your windowsills, water tables, things like that to match, we can take the same stone unit and ASTM C73 units and hone them to match. When we jump to thin clad masonry veneer, we like to say we do everything we do in full bed, we do in thin. That's almost true. We don't do very much building stone in thin because we don't really compete with some of the folks that make the man-made thin stone, but we can. But we're going to take those same stone units we've pressed in full bed. We're going to cut them into the thickness you want. This happens to be a rain screen wall stone being cut. So we've cut this into two 1 3/8 inch deep units. We will separate them so we can hone the faces so they'll match. Here we got a saw putting a kerf in each side so it will sit in the rain screen. And then we'll dry them out in the dryer because we don't want to ship water. And you can see the kerf that the rain screen wall is going to actually, the stone's going to rest in the rain screen wall system. The most standard thin stone that we make is 3/4 inch thick Renaissance. And we do these in the 4s, 8s, and 12s again. And we can do them in custom sizes. The system that is most common for thin adhered is an exterior grade sheathing. I realize in Florida, most likely it's going to be concrete masonry, we're setting these on top of. Typical is a 15-pound builder felt, Tyvek air barrier, metal lath, and a Type S or Type N scratch coat to hold the stone up. First problem with this system is our penetration of the air and water barrier, which is not a good thing. If we're going to use an air and water barrier, it should be continuous. The next thing is Type S and Type N's mortar's ability to handle shear strength. And Type S and Type N mortar barely meet code for the 50 PSI shear strength required. And if we're on a hot day in Florida or the stone's gotten dusty or things like that, people have trouble keeping thin stone on the wall. This now has been removed. Type S and Type N being used out of the scratch coat out of the National Building Code that passed sometime earlier this year. We'll start seeing states adopt it and cities adopt it soon, but just be aware of that.
Let me jump in on that.
Go ahead, Chris.
In Florida, ICC accepted the TMS 402602. We're going to talk a lot about that in the next presentation. ICC adopted it, and it was during the COVID years in 22, and the timing was not at its normal schedule, so it did not make the 8th building edition of the Florida Building Code. So that new code will affect in the 9th edition. That'll come into play. We're going to review it in the next course quite a bit, and I don't know if Matt's going to jump into it here or not, but it is coming down the line.
Yeah. So what does code say for how long scratch coat has to set before stone being applied? Minimum of 7 days, recommended 28 days. That's in most thin stone manufacturers' material. We see a lot of failures because installers basically, in this page, you can see in the background, the stone fell off the building. The installer had just put mud on the back and stuck his stones directly into the lath. And so we see lots of issues with these systems. Taking the metal into the ground, and when the metal lath rusts, it pops off. This lower right-hand corner, you see an entrance to a shopping center, stone falling off, not something you want for your client. And so the system we like, I know in Florida, so lower right-hand corner is going to be a concrete masonry wall, but with a stud wall, we're going to go exterior grade sheathing, concrete board, which is going to replace the metal lath. It's going to be screwed into the stud wall system. We're going to mud the joints. We happen to like, there's a brand of air and water barrier from Laticrete, which people are copying. This is a 2-coat system. It's a liquid. So when you put it on over your board seams and stuff like that, it does an excellent job of covering up and getting a good continuous water membrane. But it's also self-sealing. So if somebody puts a screw through it, it's going to wrap around the screw and keep that wall tight. Polymer fortified mortar is going to be our bonding agent we recommend. This is what the new building code is going to. This has got 7 times the 50 PSI shear strength required by building code. Brand name would be like Laticrete's mortar masonry veneer insulation system. And then your thin stone, your thin brick, anything like that can go on top of it. This is the system that we passed Miami-Dade NOA with, and we currently have Miami-Dade NOA with it. And so we've got projects underway in Dade County. We've also referenced a lot of projects across the state when people just want a good design that they know is going to last. Our masons on staff actually joke and say if they have to cut through a wall of masonry, they would rather cut through a full bed 4 inches of masonry wall than to cut through our thin stone over this polymer fortified mortar. An example of this polymer fortified mortar comes from Laticrete's early designs with Quarry Tile. Laticrete's the people who do a lot of work with adhering pool tiles to deck and stuff like this. And this was a shopping center built in the 1970s with their 1970s technology of adhesives. And this building was hit by an earthquake in 1993. Yeah, that's a very bad sense of humor for an earthquake. This building failed, but the Quarry Tile stayed on the wall. And that's a great example of how good the technology is with the polymer fortified mortar. This stuff will last a long time and take a beating. So what about current energy code? Maybe we're trying to get our insulation outside the wall cavity like we have with a full bed masonry unit where we framed the building with concrete masonry units, and we put insulation in the cavity, taking wall ties through the whole hold up full bed masonry. That's difficult to do with thin masonry, and the only building code helps us with is they just say to do it and reduce thermal bridging, and that's the only kind of hints they give us for wall design. And so we teamed up with a company in Ohio called T-Clear, and they make a continuous insulation board in EPS, XPS. We're kind of getting away from the mineral wool because mineral wool is very, very difficult to get these days. So lead times are very long and delayed, but we get these boards in EPS and XPS, and they have a built-in drainage cavity. As a matter of fact, you can get them with 2 built-in drainage cavities, front and back. In Florida, I would probably just go with 1 on the back side of the board, but this allows the wall to drain and the installer to put this up in 1 step. These will work with porcelain tile, thin stone, thin brick. You can put stucco over this, and using the polymer fortified mortar for any of those masonry units except for the stucco is the way to go. This is a 1-step panel. Wall system looks like this: stud wall or concrete masonry wall down low, exterior grade sheathing, air and water barrier, which would go on top of the concrete masonry unit or the exterior grade sheathing. This is a 1-step insulation, concrete board, and drainage plane in 1 step, and these are screwed into the stud walls. Now we hand you and your structural engineer the screw information so you know how many screws per board, the type of screw, the whole 9 yards, and that allows you to not have to sit there and figure out your own math on these panels. These panels are dummy proof. I say almost dummy proof because we've had some projects where some guys tried to VE these off, and they said that these were cheaper than actually putting up a 3-step drainage mat, insulation, and cement board outside. Now, what's a concrete board? A concrete board is a little bit stronger board than a cement board. And so the screws, again, are going to go through the concrete board into the stud wall. A lot of systems have insulation with a fiberglass mesh over top of the insulation, and they have people gluing masonry units to that fiberglass mesh. I'm not real fond of a panel that has no hard surface to bond the stone to and create a mechanical fasten as well. So that's a good system. And we're going to tape these joints, put up the polymer fortified mortar, and put our thin masonry on top. We have CAD drawings online at Ariscraft to meet fire code for all these details. And so we've been through fire testing on that, and we can help you with the logic of getting how many hours you can get out of these wall systems. These panels look something like this. These are on the left is the double drainage plane. You can see the some holes appearing between the concrete board and the insulation. And on the right is a single drainage plane. You can get these from 1 inch, an EPS from 1 inch to 6 inches of insulation in 1/4 inch increments. Some architects will design with these just to change the wall thickness so they get a, so they can making changes in the vertical plane of their wall and add details. And of course, if you're going with stucco, this is a nice hard surface under the stucco to give you a little bit more resistance to damage. These can be laid in any pattern on the wall. They don't add any, they do add shear strength, but not much. And so if you're laying them up in running bond and stuff like that, that can help. That does have a Florida product code with this system as well. And so does with this product as well as do all the Ariscraft products. Here's kind of a running bond version of this. You can put these up any way you need to. There is a panel that is 1 foot by 8 feet that we do at the base of the wall. This is the wheat board to get the water out of the wall. In that circle picture in the middle, you'll see a little weep that goes around it. When we first introduced this system about 7 years ago, we shimmed the wall for it to drain. We found out this was a better way to do it. And again, we've got CAD drawings to help you with all the detailing to meet code. Here's a wall going up. That is the Laticrete air and water barrier liquid rolled on. And the rule of thumb of that material is if you can read the brand of board sheathing underneath, that's on too thin. The ProGuard panels are going up, screwed in place. We share these drawings with the general contractor and the mason on how the screw properly going in. We don't want the mesh in the board broken with the screw head. We use 2-inch washers, not on every screw. We want these actually just on the butt end of the board to level the boards out, because that's the most difficult part of the wall to keep level. So the stone or thin brick going on top will look good. We share these drawings with the installers to understand that a butt joint is better than any other type of joint. We got a nice solid surface there, so the insulation stays continuous. Then we're going to lower left-hand corner. We're going to use some tape to create a corner, and then middle bottom mud the corner before the stone goes on top. These are our masons cutting a miter joint in the field. It's difficult to cut a miter joint solid, so we like to share these drawings with the installers, so they try to use the butt joint as much as possible to keep the insulation continuous. Again, we've got the NFPA 285 compliant drawings we'll share with you to get this right, and all the other drawings to keep the wall systems, whether you're using the fireproofing or not. It's examples of walls going up. We've got a project like this in Miami. It's in the Arts District, and it's actually these three colors. It's not these three colors, it's three different colors, but it's a tile going up on a building down there. And with Oldcastle Pompano's actually doing this job, we're done with it now, so it's going to look good. Here's a project in West Lafayette, Indiana. This is has an insulation panel underneath this, where they took the tile and went vertical with the lines. This is a project in Pittsburgh, Pennsylvania, where they went 2 stories of full bed stone, 5 stories of thin. We tell the story on this that the installer got this job. He was one of these installers, as a mason, who is infamous for wanting to change everything on the building. And so this is a Hilton property. Hilton's very good to us. They held the spec on the stone. So we got the order for the full bed stone for the first 2 stories. We got the order for the Arris tile, the 3/4 inch thick stone for the rest, but we did not get any orders for the insulation panels. And so we figured, they were trying to figure out a way around this and do a value engineering move. And eventually, when we got the order for all of the insulation, one of our sales guys went to visit this installer, or this mason, and he said that this was, it was a very idiot-proof system. He was trying to VE it. He said it was actually more expensive to do it in layers than to just buy the more expensive panel and do it in one step. And he also added that he said the screw pattern and pre-engineered information was worth $50,000 because when he went to an engineer to try to get them to help him with a means of putting these up without using our screws and our information, he said the structural engineer wanted $50,000 to figure out the math. So that's the story on that. Lots of projects around Florida. This is one up in the Jacksonville Beach area in Ponte Vedra of an Arris tile on a house. Bank at Tampa. This is a tilt up job. Client did not want a stucco finish. They still wanted white, and so they used our Arris tile 12x24 in our whitest color, which is limestone. We'll take those same stone units and we actually split them into smaller units to give the appearance of building stone. We take one of those 12x24 units and we break them up. So here they are going into the machine. Here they are coming out of the machine. Actually, they're being broken right here. We don't want these all the same thickness, so they'll break in different spots. Here they are coming out. And to get a random pattern, we need units in different lengths. And so the installer will just take these units and use a little quickie grinding tool to square them up and put them in the wall to help create the bond. We make all these in 2-foot lengths. When we cut corners, we take units, shorter units, feed them into a double saw. And when they come out at the other end, the center's been cut out. We have a nice square unit that goes with the stone in the wall. Project near Tampa of our darkest color in stack stone. Stack is a 3-face rise unit that goes together. This was our very first Miami-Dade project. This is a Camden property multifamily unit. we'll take this material inside. University of Arkansas Children's Hospital. We'll take that same material and sell it in the different units. So if you wanted just one unit to maybe create a 2 1/8 inch long linear unit, or 3 5/8 or 5 7/8, we'll saw the smaller units, the 2 1/8 and 3 5/8 to create a sawn texture. Different style stones in the wall. And I like this. This is just a neighborhood pool where they wanted nice long linear lines to go with the porcelain tile at the entranceway. So they thin adhered over the entrance walls into this pool. And here is their commons area. This is a school in Massachusetts where it's a thin applied stone. They wanted this curve cut in both the large format tile and the building stone. And so we actually cut it at the factory and lettered the pieces of stone so they knew what went together where. In the past few years, we've introduced elevation thin brick. This is a 2 1/4 inch tall, random length up to 23 5/8 inch unit. This has become very popular. This can make for a nice uniform wall if you want your wall to be very flush. This is our first project. I think this is in someplace in Manhattan. On the left side of this white building is the elevation thin stone. On the right is a sawn stone with various thicknesses. They wanted lines on one side of the building and they wanted to be flush on the other. Thin applications for renovations. This is a bank in the suburbs of Atlanta in Cartersville, Georgia. They just wanted to update a 1980s red brick bank. And the cool story on this was this bank never closed during construction. So they put a new entrance on this, Arris tile entrance, rock texture, base wainscot on the building, some columns going up, and some window surrounds. And I happened to be out on the job site when they were cleaning it. The bank president told me that they never closed the bank during construction. Chris, before I go into range screens, you want to take a few questions here?
You know, we're doing really good, quite frankly. We haven't had a lot of questions. You got roughly 5 minutes to go, and I know you got a little bit to go. So let's just jump right back in.
I'll keep going. So range screen wall system, same stone we make. Instead of making it 3/4 inch thick, we're going to make it 1 3/8 inches thick. So it will take a kerf and set in a stone panel. We're going to start with stud wall or concrete masonry wall, lower right-hand corner, shear grade sheathing, air and water barrier. Again, we like the Laticretes because it's self-sealing. Aluminum discrete girt is going to be the bracket that holds this framework onto the building. Cavity insulation in between, if needed. Sometimes we'll see projects that are just putting up a new veneer on a building and they won't use cavity insulation. That just depends on the job. The aluminum Z channels are kind of like our studs.
Yes, Doug.McCall and then Craig.Akers and then the @oldcastle.com.
Hey, Chris, we can hear you.
Oh, sorry.
And then the stone channels are going to go into the aluminum Z channels. And then the stone clips into place. Now, this is the calcium silicate stone. These are in 1 foot by 2 foot units. And then you can do as a closed system with backer rod and sealant, or an open system with a inserted vent so the wall is open and breathes. If you're specifying in the man-made calcium silicate stone units, on the left, you'll see a wall going up. Those are 1 foot by 2 foot units. You can see the bracket system going up. On the right, lower right-hand corner is the natural stone. We can cut those into panels as much as 30 inches by 72 inches. And so we can do those as well. Here happens to be a project that we had a lot of fun with at University of Southern Indiana. They turned the tile upwards, so it's 2 feet tall and 1 foot wide. And in between are 2 feet tall and 6 inch wide units because they wanted kind of a cedar shake look on this building. This is a University of Central Florida Lake Nona hospital where they use the range screen wall system. Some projects we do full bed masonry and we'll just do the soffit details and stuff like that. But this entire building is all range screen. This is a healthcare campus in Charlotte. This is the one that they wanted their own stone color. And so for Atrium Health, so we made them their own stone color to start their campus. Another hospital project. I think about, full bed masonry. If you wanted to do those bands on the upper right-hand corner for those ribbon windows, or that unique detail upper left-hand on the picture on the left where we've got that free wall going across top, that would be expensive to do and carry the load with full bed masonry, but with a range screen wall system, not so difficult. There's a mid-rise in Portland, Oregon. Had to meet seismic standards out there for this range screen wall system. Now, the range screen wall system won't meet Miami-Dade standards because it's the impact resistance. We would fail there on that. Upper left-hand corner, they did an addition onto a brick building and lighter weight wall system just applied. So when you're doing this type of detailing, Arriscraft has 2 architects on staff. We have got lots of drawings to help you get through the detailing on how these walls go together. Soffits seem to be the most challenging. And so feel free to call us, lean on us at any time for this detailing. This is one of my favorite case studies. This is in Columbus, Ohio. This was a quick brick building that never stopped leaking. They had design issues with the way the wall went together. And so they tried to seal it. They tried to put up different coping, drop the coping down lower, stuff like that. And after a few years, they actually just decided they'd tear this building down and build a new one. Architectural firms sat through a lunch and learn with us and saw an opportunity to kind of separate themselves from everybody else and proposed putting a range screen wall system over top of the good bones of the concrete masonry unit building. And this was the before pictures. This is a 5-year-old building having water issues. And so, there's some issues there with the manufacturer, I guess, I don't know. And here was the post recladding pictures. And they said this was on the fire training campus in Columbus, Ohio. And so they said the new challenge was this was a much prettier building than the old buildings on campus. So now what are they going to do? So, hey, we're all for supplying some more buildings. And there's the Fireman's Memorial. Old stucco building, it had good bones. And so they ripped the stucco off and put up a range screen wall system. Old red brick building, they just wanted a new look. And so they reclad this. And we make all kinds of shapes and details in the tile as well. So curved edges, bullnose, windowsills, things like that. And this is probably the most common detail, soffit, upper left-hand corner. I wouldn't want to thin it here, a lot of people will do it with no issues, but that's an anchored range screen wall system, as well as this vaulted entrance on the right. On the right is a full bed brick and stone building with only the arch there in a clip system. And here it is going up. So those are mechanically anchored, and then you would fill the joints, point them up.
Matt, I wanted to make sure you got to that one because that was a pretty cool detail, but we're hitting right on time and they're about to go grab lunch.
Okay,
so
let me just say one more thing.
Design tools to wrap it up, and then I think we'll be good.
Yep. CAD detail library. We have over 7,000 drawings online. We have catch patterns and seamless images online available. If you can't find one, let me know or let Chris know. We have installation and care guidelines online, specs online, technical videos. We'll do a building envelope review. We're members of the BIA, the National Concrete Masonry Association, and we support the Cast Stone Institute. Follow those guidelines. And lastly, not least, our carbon footprint is very low with this product. 1/3 of that of clay brick, 1/2 that of concrete masonry units. Sand and lime are pretty much inexhaustible natural materials. We fire with natural gas. We use heat exchangers. We suck heat off of autoclaves going down to use them to warm up autoclaves going up. We recapture over 90% of the water used in our process. Material, of course, can be crushed, you saw earlier. Lightweight solutions can put more square footage on a truck. And of course, the new wall systems can help out. And that's it. Thank you for your time.
Perfect. One last thing I want to throw out there is Fort Georgia well, I'm based in Orlando. That's what I think 6 hours or so drive.
Yes,
It's a cool plant. And if anyone wants to look at it with their client or their customer or design team or construction team, by all means, what most of the presentations we do with this product, quite frankly, is job specific, where we go through and sort of brainstorm what's the best system to go on the wall, because they're so versatile in what they have. But we have a number of courses available with them. Beyond that, thank you all very, very much. Matt, I don't know if you have anything to add, but thank you all. And what are we looking at, Wendy? 115s for next one?
Yes, sir.
Okay, good deal. Go ahead, Matt. You got anything else to
Well,
finish?